I know what you're thinking. Jeremy, this subnetting has been so amazing. I just don't think it can get any better. Oh. Of course it can get better, because we're about to dive into additional subnetting practice where we look at additional examples of subnetting based on host requirements to solidify this concept. I promised you when we started this subnetting adventure, I'm like, you're gonna get this, and I know that you will. I know, even if you're like, watch it again. Watch it. I have taught, this is, so I have been teaching subnetting for like 1990. Like I've taught it long enough that I'm like, I know you're gonna get this. So if you're still struggling a little bit, just keep watching. It's gonna come to you, and it's gonna be like, that's amazing. I love this. So let's do this. We're going to go through additional examples using the 3-step subnetting process based on the number of hosts. So I've changed the stories a little bit, right? So let's do this. For the problems below, determine the correct subnet mask and find at least 3 network ranges. Okay, so number 1 says, given 200.5.1.0/24, so this is our class C example right here, break it into subnets of at least 50 hosts per subnet. Okay, 200.5.1.0/24, 50 hosts per subnet. I'll just abbreviate that right there. Okay, step 1, convert the number of networks to binary. Oh, whoops. Use my copy and paste of my same slide of hosts. It's the same thing, right? So 128, 64, 32, 16, 8, 4, 2, 1. And our 1 is going to go right there. We immediately know that's 6 bits. So to get the number 50 is 6 bits. Now I'll ask you the question, are we creating more networks or saving the hosts? And you would say, saving the host. So when we take that /24 and write a whole bunch of 1s, and I'll show you how I shortcut this when I'm doing them quick, dot 1, 2, 3, 4, 5, 6, 7, 8. So I'll write the 24 1s as just like, yeah, I know there's 24 there. The zeros are my playground, right? That's where I can play around with stuff. So I'm going to say, okay, I need to save 6 bits. I'm saving the hosts. That's right to left. 1 I've saved, 2 I've saved, 3 I've saved, 4, 5, 6. The other 2 I could not save. They flipped over to the network side. So our new subnet mask goes to a /26 because we had our 24 right there and we added 2 more. Or if you want to write that in decimal, it's 255.255.192. Lowest network bit is our increment, and that is 64. So watch this. I'm going to go 200.5.1.0. This is the start of each one. 64, 128, 192, and what's this last one? 256. And we know that anytime you reach 256, you're done. You've reached the end. So fill in the end ranges: 63, 127, 191, 255. Now, here's the interesting thing. And I think we've run into this before. Maybe I just haven't pointed it out. That's it. You can't subnet that anymore. Because you wanted networks of 50 hosts each, and by the way, we actually get 62, because it's 64 minus 2, 62 usable IP addresses on each one of those networks. Because you wanted networks that big, and because you started with a Class C address, you just tapped it out right there. The most networks that you can get is 4 networks. And I know I might be stating something obvious to you, but I just figured it'd be worth pointing it out. You can exhaust your subnets. Cool. Number 2. Given 150.5.0.0/16, there's our Class B example, break it into subnets of at least 2,000 hosts. 2,000. Okay, guys, you want to know what's wrong with you, Jeremy? It is 9:25 at night. I literally got home from my son's baseball game, and I'm like, Sue, it's my wife. I'm like, I'm going in. I'm teaching more stuff. I told her, I'm like, I'm fired up. I want to finish it. I want to get through all this. So I'm a little bit loopy. I've been teaching for I don't know how many hours straight. So break it into 200 hosts, not 2,000 hosts, right? You good with that? Let's write it up. 150.5.0.0/16, 200 hosts per subnet. Cool. All right, so convert the number of networks to binary. We've got 200. I'm giggling at myself because I know I just thought of, you'll see why I'm giggling. So 128, 64, 32, 16, 8, 4, 2, 1. Okay, so 200 is... our first one goes right there. It takes 8 bits to get the number 200. Okay. So /16. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Cool. Are we creating more networks or saving the hosts? Saving the host, my friend. So, right to left. 1, 2, 3, 4, 5, 6, 7, 8. Because it takes 8 bits to get the number 200. Dot. And the rest of these flip on over to the network side. And you would, now you can see why I'm laughing. You're like, Jeremy, didn't you just put a Class C subnet mask on there? You bet I did. So the new resulting subnet mask is 255.255.255.0. Our increment is a 1, right? Now do you understand why everybody defaults to Class C? Even though you don't have any idea what subnetting is, you're actually doing subnetting when you just slap a Class C address or mask on an address because your increment is 1. So our networks look something like this. Next one, 150.5.1.0.2.03, right? Very simple, but now at least you can see the magic behind why the Class C network works so well. 155.0.255.1.255, right? And all the way down. So essentially, we landed on using a Class C subnet mask and applying it to a Class B network. That's funny. Last question. Given 10.0.0.0/8, which is our Class A network, I want to break that into subnet containing 4,000 hosts each because we're crazy, right? Because you wouldn't normally make subnets that big, but it sounds fun. Let's give it a try. 10.0.0.0/8, 4,000 hosts per subnet, right? So convert the number of hosts to binary. We've got our 4,000. Oh, hang on, 4,000. So we're gonna go 128, 68, and you know all those. Because immediately I'm stopping because I'm like, we know that we can't get 4,000 with 8 bits. So we just keep going. 256, 5, 12, 10, 24. Would that be 20, 48, 4,000? I don't go this far very often. 4,196. Right? I could stop right there because I've passed it, and I can't put a 1 right there. That's a 0. My first one goes right there. So if this is 8 bits right here, 9, 10, 11, 12. It takes 12 bits to get the number 4,000. Isn't this cool? Even though it's like insane sounding, you can figure it out. It's actually not that bad. So 12 bits. So hang on, let me just give myself a little room here. A little room, people. 8, 1, 1, 1, 1, 1, 1, 1, 1, dot. Then we've got a whole bunch of zeros. Again, you can shortcut the ones like I showed you on one of the previous examples. Don't shortcut the zeros. You want to be able to see where those lines are coming in. The zeros are your playground. I'll say it again. So we're saving the host. We're saving 4,000 hosts per subnet. So right to left, 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, right? Total zeros. So that's where our, oh man, that's where our line goes. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. That's our new subnet mask. So our /8 goes to a /16, 17, 18, 19, 20, or 255.255 dot, what would that be? 240.0? Yeah. Our increment is in the third octet. Got our little line right there. 128, 64, 32, 16. And now we use that increment to generate really big network ranges. 10.0.0.0, 10.0.16.0, 32.0.48.0, and down and down and down we go. This goes through 10.0.15.255.31.255, and down and down and down we go. Yeah? Yeah? Isn't this cool? That's it. I mean, if you get that, if you're like, yeah, I really get that, and you just flow through those examples and you're like, I'm doing this. Like, just make sure that you can do it. I know I get fired up. I'm like, go. I pause, erase your mind, just come up with some go on Google, search for subnetting examples. There's a cajillion of them out there where people are doing this. Now, again, I'm showing you two different processes: subnetting based on the number of networks, subnetting based on the number of hosts. I've got two more to show you. One will be reverse engineering, which is actually the most common form of subnetting, and it's the easiest. You're going to love it. And I'm going to do one more skill on variable length subnet mask, or VLSM. Once you've got those two down, there's nothing, literally nothing somebody can throw at you, and you'd be like, what? I mean, you've got it. And this mindset that you're developing as you're going through this, as you get into TCP IP version 6, you're going to look at that subnetting and be like, easy, piece of cake. Right. I'm going to bed. Have a good night. Oh, wait, hang on. Traditional. You have now seen additional examples of subnetting based on network requirements. Oh, man. Host requirements to solidify this concept. I hope this has been informative for you, and I'd like to thank you for viewing.